So let's look at a different example. We have an example here, and what's going to happen is we're going to find one eigenvalue for this system that has three equations, three unknowns, and we're only going to get one eigenvector. So similar to the last problem where we had one eigenvalue and one eigenvector, but that was two equations, two unknowns, we had to find a way to find x2. So we're still going to have to find x2, but now we're going to need a way to also find x3. So here's our way to find x3. We'll have this vector p because we will find that during the process for finding x2, but now we're going to use that to find q. So let's talk about the process we're going to use here. We're going to go through, find the eigenvalue, find the eigenvector. That's going to give us our first solution, x1. Then we're going to go through and we need to find a p-value. And we can find that p-vector by solving this. Remember, lambda is the eigenvalue, k is the eigenvector. And then once we have that, then we're going to set up another system. And we're going to find this q vector. So let's take a look at this problem. Our first step is to figure out what the eigenvalues are going to be. So we need to find the determinant of a minus lambda I. So here's what the matrix is going to look like. So this guy is what's called a triangular matrix. It's actually upper triangular. We have things down the main diagonal and we have stuff above. We do not have anything below. So there is a shortcut for this guy. It turns out that the determinant of this matrix will be the product of the entries down that main diagonal. So we're going to have 2 minus lambda cubed is equal to 0. Take the cube root of both sides, move lambda over, you're going to get 2 for your eigenvalue. So now that we have the eigenvalue, let's find the eigenvector. So to find the eigenvector, we're going to substitute that into this matrix. And we are going to have 0, 1, 6, 0, 0, 5, and 0, 0, 0. Let's solve this system. If we did RREF, we will end up with this. So what this tells us is x2 is 0, x1 is 0, x2 is 0, x3, so this is in the x3 column, is 0, and x1 is going to be free. So our eigenvector is 1, 0, 0. Make sure you put these in the order, coefficient of x1. That's our k value. I'm going to label this because we have a few other things we need to find. So now we want to solve the system. A minus lambda I times p is equal to k. So let's see what this system's going to look like. If we were to type 2 into this matrix, we're going to get that. P is what we're trying to find, so I'm going to call this P1, P2, P3. And our K value is 1, 0, 0. So now we have the system we want to solve. I'm going to rewrite this as an augmented matrix. And then we're going to use RREF. So if we do RREF on this one, here's what I got when I typed it in. So this tells me x2 is equal to 1, x3 is 0, so that makes x1 the free variable. So remember, just like before, we can let that be anything. I just realized I'm using the wrong variable. Since we used p's over here, let me change these to be p, which would make this a little bit more consistent with our notation. So let's let p1 be 0. Okay, you can pick any number you want to for p1, because remember, p1 can be anything. But to be easy, I'm just going to be 0. So if p1 is 0, p2 is still 1, p3 is still 0. So there's our p vector. So we have x2 now. And this goes back a few pages in the notes. x2 is still going to keep this format even though we're talking about 3 equations, 3 variables. So x2 is still going to be the eigenvector, which for us is 1, 0, 0. Times e to the 2t times t plus our p vector times e to the 2t. So now we got to find q. So we want to solve another system. A minus lambda I q is equal to p. So let's see what this is going to look like. A minus lambda I is still the same matrix we used above to find p. We are now looking for q1, q2, q3. And we just found p as 0, 1, 0. If we write this as an augmented matrix, it would look like that. So now, to solve this, we're going to do RREF. And that will give us, here's what I got. So what this tells us is Q2 is negative 6 over 5, Q3 is 1 over 5, and Q1 can be anything. So once again, you can pick your favorite number for Q1. I'm going to pick 0. So then my Q vector will be 0, negative 6 over 5, and 1 over 5. So let's talk about what x3 is going to look like. x3 is going to be fun, y'all. So x3 is going to be our eigenvector times t squared over 2 e to the 2t plus our p t e to the 2t plus our q e to the 2t. And that format comes from this guy above. We're using that. So then what does the general solution look like? Well, it's all that stuff kind of squished together. So x is going to be C1. Don't forget your constants when you're writing this. So this is going to be 1, 0, 0, e to the 2t. That was the easy one. That was the first one we found. Plus it's going to be C2 times all of this. Plus it's going to be C3 times all of that. So there's our general solution for this particular problem.